Hello, today we're going to see the solution for a problem in module 4. So let me share the problem with you. What the problem says, and this is problem 4.1.1c type. These problems gives you a matrix A, and this is a 3x3 matrix, and it is asking you which one of these statements is true. And if you read each of the statements, they all refer to the same type of questions. They give you a vector V and ask you if that is an eigenvector corresponding to a given eigenvalue. So to solve this problem, what we do is we use the definition given in module 4.1. So this is a definition of what it means to be an eigenvector corresponding to an eigenvalue for a matrix A. And what this definition tells you is that we need to check if it's true that when I multiply A times my given vector V, that's going to be the same as just multiplying the corresponding lambda times the vector V. So that's what we're going to check for each of the three cases. So for the case 1, let me copy here my matrix, -10, 6, -12, -34, 19, -44, and -8, 4, and -11. So when I do A times V, this is A, my given V is the vector -2, 1, 2, that I can see that's a 3x1 matrix. And we just need to do this computation. Just a quick reminder, this is a 3x3 matrix. This is a vector can be seen as a 3x1 matrix. And what we always check is for this to be well defined, these two numbers need to match and they kind of cancel. So what you end up getting is going to be a 3x1 matrix that we see it as a vector. So let's do the computations for this. So this row is going to be matched with each of the entries of the vectors. So it's going to be -10 times -2. Then this one with this one will give me +6 times 1, and then -12 times 2. And when I simplify this, that will give me my first entry. So for the second one, I'm going to get -34 times -2 plus 19 times 1 minus 44 times 2. And finally, -8 times -2 plus 4 times 1 minus 11 times 2. So when I simplify it, the first entry is going to be 26 minus 24, so that's -2. This is positive 68 plus 19 minus 88. That gives me -1. And then positive 16 plus 4, so that's 20 minus 22. So I get -2. Let me just double check. Positive, and this is positive too. I did have some correction there. Okay. So when I multiply A times V, I get 2, -1, -2. The question is it true that this is equal to lambda, which is -1 times this vector -2, 1, 2? And the answer is yes, because if you see, this is just switching the sign, and indeed that gives me this. So this is true. And now we just need to do the same procedure for the other two matrices. So I reviewed how to multiply matrices. You should have that down. You should feel comfortable with this. So I'm going to let you do that on your own and just show you what you should get. So for the second one, I'm copying my matrix here. My second vector is going to be 0, -2, -1. So I do my product. So I get 0 plus 6, sorry, -12, and then plus 12, that does give me 0 here. And then in the second entry, again, you can do this, I should get 6. And then for the third one, that's 0, -8, plus 11, so that's 3. Again, the question here is this equal to, and for this one, my lambda is equal to 2 times my original vector, this one that I have here, 0, -2, and -1. And you can see already that this does not agree. So this is not true. And the answer is this is false. And finally, for my third case, I have that AB will give me just erase a couple of things here. That's my matrix A. My vector B in this case is 1, 2, 0. So I need to do again the multiplication. And that will give me the vector. So let's see, it's -10 plus 12 plus 0. So that's going to give me 2, and then -34 plus 38 plus 0. So that's 4, and then -8 plus 8 plus 0. So that does give me 0. And then for this one, the question is this equal to lambda, which in this case is 2, times my original vector 1, 2, 0. And of course, the answer in this case is yes. So this is true. So in this case, what we end up having is the only ones that are true are 1 and 3. So let's look up. 1 and 3 corresponds to answer choice F. So that's how you figure out the correct solution in this problem.